Hello guys, this is Cleophas from On My Space Tutors. In this video, we will be looking at differentiation. Specifically, we will be looking at the general rule of differentiation. The general rule of differentiation is also known as the power rule. So what does the power rule state? The power rule states that if you are given a function y is equals to ax raised to power n, then its derivative with respect to x is given by n multiplied by x raised to power n minus 1. So what happens in the process of differentiating using the power rule is that the power on the independent variable is actually multiplied by the coefficient before the independent variable. So we can see that this power n is here. It has been multiplied by the coefficient before the independent variable. And then the power on the independent variable is reduced by 1. Hence, the name, the power rule, because the operations are basically being performed on the power. Now, we are going to look at how to use the general rule of differentiation in obtaining the derivatives of functions. So, in our first example, you have been asked to differentiate y is equals to 8x raised to power 3 with respect to x. So, how do we do this? First, we shall state the general rule of differentiation, which provides that given a function y is equals to ax raised to power n, then the derivative of y with respect to n is given by n multiplied by a multiplied by x raised to power n minus 1. So in this case, you have been given y is equals to 8x raised to power 3. So if we compare this with the general rule of differentiation, then it means that a corresponds to 8 and 3 corresponds to n. In other words, 3 is the power and 8 is the coefficient before the independent variable. So what we do is that we take the power, which is 3, and then we multiply this power with 8, which is the coefficient before the independent variable. That is 3, the power, as shown here, multiplied by 8, the coefficient before the independent variable. And then the next part is that we take the power and we subtract by 1, as shown here. Next, we simplify this expression. First, we take 3 multiplied by 8, which will give us 24. And then on the power, we take 3 minus 1, which will give us 2. In our second example, you have been asked to differentiate y is equals to 3x raised to power negative 4 with respect to x. So what we are going to do is that first, we shall state the general rule of differentiation, which provides that given a function y is equals to ax raised to power n, then the derivative of y with respect to x is given by n multiplied by a multiplied by x raised to power n minus 1. So in this context, you have been given y is equals to 3x raised to power negative 4, in which case a corresponds to 3, whereas n corresponds to negative 4. So according to the general rule of differentiation, we shall take the power, which is negative 4, and then multiplied by the coefficient before the independent variable, which is 3. And that is what we have done here. We have taken negative 4, the power, and we have multiplied by 3, the coefficient before the independent variable. And then we have gone ahead and that on the power, we have taken negative 4, which was the power, and we have subtracted 1. So the next step is to simplify this expression. First, we shall take negative 4 multiplied by 3, which gives us negative 12. And then next, we have taken negative 4 minus 1, which gives us negative 5. In our third example, you have been asked to differentiate y is equals to x raised to power 12 with respect to x. So first, we shall state the general rule of differentiation, which provides that a function y is equals to ax raised to power n. Its derivative dy dx is given by n multiplied by a multiplied by x raised to power n minus 1. So in this case, the function given is y is equals to x raised to power 12. So according to the general rule of differentiation, we take the power, which is n, and then we multiply by the coefficient a, which is the coefficient before the independent variable as shown here, and then the power n is reduced by 1. So in this case, the power is 12. So we are going to take the power 12 and we multiply it by the coefficient before the independent variable, which in this case is 1. So 12 multiplied by 1 gives us 12. Hence here we have 12. And then the power, which is 12, we reduce it by 1. Next, we simplify this expression. That is, the power, we have 12 minus 1. 12 minus 1 gives us 11. So in our fourth example, we have been asked to differentiate y is equals to 1 over x raised to power 3 with respect to x. So how do we go about this? So first of all, we shall apply the law of indices on negative powers, which provides that 1 over a raised to power n is equivalent to a raised to power negative n. So in this case, we have been given 1 over x raised to power 3, which is the same as x raised to power negative 3. So our original equation, which is y is equals to 1 over x raised to power 3, can be still expressed as y is equals to x raised to power negative 3. Next, we apply the general rule of differentiation, which provides that given a function y is equals to ax raised to power n, then its derivative with respect to x is given by nax raised to power n minus 1. So in this case, we have the function as y is equals to x raised to power negative 3. So the power on the independent variable is negative 3. This shall be multiplied by the coefficient before the independent variable. In this case, it is 1. So if we take negative 3 multiplied by 1, it will give us negative 3 as indicated here. And then we go ahead and on the power, we shall take negative 3 minus 1. Next, we simplify this expression. That is, negative 3 minus 1 gives us negative 4. In our fifth example, you have been asked to differentiate y is equals to 2x raised to power 4 plus 3x plus 6 with respect to x. So what we're going to do is first of all rewrite our original function as y is equals to 2x raised to power 4 plus 3x raised to power 1 plus 6x raised to power 0. So what we have done is that we have taken x, which is a single x, the same as x raised to power 1. And then on 6, we didn't have any x, but we have put x raised to power 0, since we know that any number raised to power 0 is 1. So by doing so, we haven't changed the value of 6. After all, 6 multiplied by x raised to power 0 is actually still equals to 6. Then, next, we apply the general rule of differentiation. So in this case, in the first term, we are going to take the power, which is 4, we multiply by the coefficient, which is 2, as seen here, 4 multiplied by 2, and then the power, we reduce it by 1. Again, we apply the general rule of differentiation on the next term, which is 3x raised to power 1. That is, we take the power, which is 1, we multiply by the coefficient, which is 3, and the power we reduce by 1. And then on the last term, we take the power, which is 0, and we multiply it by the coefficient, which is 6, and then the power, we reduce it by 1. Next, we simplify the expression. 4 by 2 gives us 8, and 4 minus 1 gives us 3, whereas 1 multiplied by 3 gives us 3, and 1 minus 1 gives us a 0. So 0 multiplied by any number should give us 0. So the whole of this term will be 0. We go ahead and simplify further. We shall have 8x cubic, and then here 3 multiplied by x raised to power 0. So x raised to power 0 is equivalent to 1. So this means that we shall end up with 8x cubic plus 3, since 3 multiplied by 1 gives us 3.